On July 1st, 2025, a telescope in the middle of the Chilean desert caught something moving that should not have been there. It wasn't an asteroid. It wasn't a planet. It was moving too fast, on a path too straight to belong to our solar system at all. Astronomers gave it a clinical, almost forgettable name, 3I Atlas. But what they were looking at was only the third object in recorded human history confirmed to have come from another star system entirely. And now, more than a year later, new data from the James Webb Space Telescope is forcing scientists to admit something unsettling. They got the size, the age, and the danger of this object badly wrong the first time. So tonight, we're asking the question, a growing number of astronomers are no longer afraid to say out loud, what if 3I Atlas isn't just bigger than we thought? What if it isn't done surprising us yet? Let's start with what we actually know, because the real story here is strange enough without adding anything to it. On the night of July 1st, 2025, the NASA-funded Atlas survey, the Asteroid Terrestrial Impact Last Alert System, based in Rio Hurtado, Chile, flagged a faint, fast-moving dot near the orbit of Jupiter. Within hours, follow-up observations confirmed the impossible. This object was on a hyperbolic trajectory, meaning the sun's gravity could never hold it. It wasn't orbiting us, it was just passing through, on a one-way trip from somewhere else in the galaxy, moving at roughly 137,000 miles per hour and accelerating as it fell toward the sun. Astronomers scrambled to pull pre-discovery images from archives, old telescope data that had unknowingly captured the object weeks earlier, and traced its path back to at least June 14th, 2025. It became only the third interstellar visitor ever confirmed, after Oumuamua stunned the world in 2017 and Borisov followed in 2019. Here's where it gets interesting. When Hubble first turned its lens on 3I Atlas on July 21st, 2025, the comet was still 277 million miles away, and the picture it sent back was frustratingly blurry at the edges, a teardrop-shaped cocoon of dust wrapped around a nucleus scientists genuinely could not pin down. The early size estimate was a strangely huge range, somewhere between 440 meters and 5.6 kilometers across. Read that again. Astronomers didn't know if this object was small enough to fit inside a city block or big enough to swallow Manhattan. That's not a rounding error. That's a scientific instrument admitting it's staring at something it cannot fully resolve. And the not knowing didn't stop there. As the months went on, and 3I Atlas raced toward its closest approach to the sun, on October 29th, 2025, its brightness kept behaving in ways that didn't match a simple, predictable snowball of ice. Now here's the twist most people online never got told, because it never fit a cover-up narrative. NASA didn't hide this data. It published it, openly. Hubble, Webb, TESS, Swift, SphereX, the Perseverance rover, the Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, even the Parker Solar Probe. An entire fleet of NASA assets was quietly pointed at this one object as it crossed our solar system. That is not the profile of an agency trying to bury a discovery. That's the profile of an agency that knew it was looking at something scientifically priceless. And in June 2026, the payoff came. A team led by Martin Cordner at NASA Goddard, using JWST's NIR spec instrument, published results in the journal Nature that stopped astronomers in their tracks. 3I Atlas showed a methane-to-water ratio roughly 11 times higher than any object ever measured in our own solar system. 11 times. Not a small deviation. A chemical fingerprint unlike anything we've ever directly sampled before, sitting right there in the data, confirmed and peer-reviewed. And that same JWST dataset delivered something even stranger just weeks later. Based on the June 2026 readings, scientists now estimate 3I Atlas could be somewhere between 10 and 12 billion years old, a wanderer that may have formed before our own sun even existed, drifting silently through interstellar space for longer than most of human history could conceptualize, only to arrive here, in our neighborhood, on our watch. Separately, a team working with the ALMI array in Chile found something else in the comet's water, 30 times more heavy water than a typical solar system comet contains, and more than 40 times what's found in Earth's oceans. These aren't fringe blog claims. These are numbers published in Nature and Nature Astronomy, sitting in the same scientific record NASA stands behind. So by mid-2026, the picture of 3I Atlas had completely changed from the blurry dot first spotted in Chile. It was older than the sun, chemically unlike anything cataloged before, and its true physical size was still, in some estimates, uncertain by a factor that would make any engineer nervous. That uncertainty is exactly where one Harvard scientist decided to plant his flag, and where the loudest, strangest scientific argument of the decade began. Because while NASA quietly built the most detailed picture ever assembled of an interstellar object, one astrophysicist was reading the exact same data and reaching a conclusion that would divide the entire field in half. His name is Avi Loeb, and by early 2026, he had become the single most talked about scientist in astronomy. Not because everyone agreed with him, but because almost no one did, and he refused to stay quiet anyway. Loeb is a tenured Harvard astrophysicist, not a random internet theorist, and starting in July 2025, just weeks after 3I Atlas was discovered, he co-published a paper laying out a case that most of his colleagues considered close to unthinkable, that the object might not be a comet at all. It might be technology. His argument didn't come from nowhere. Loeb pointed to the sheer improbability of the object's flight path, its trajectory, aligned to within 5 degrees of the ecliptic plane, the flat disk along which our planets orbit the sun. He calculated the odds of a truly random interstellar object lining up that precisely with our solar system's plane at just 0.2%. Add to that the early mass estimates. By September 2025, Loeb was telling reporters the object weighed in at over 33 billion tons and spanned at least 3.1 miles across. Numbers that, if accurate, would make it dramatically larger and more massive than anything astronomers expected an interstellar wanderer to be. He also zeroed in on a detail that a lot of people found genuinely eerie. The comet, for a while, appeared to lack the kind of long, flowing tail you'd expect from a body actively venting gas and dust as it neared the sun. Comets are supposed to look like they're melting. This one, in Loeb's telling, didn't behave the way it should. Then came what people started calling the nickel anomaly. Spectral data suggesting the presence of nickel in the comet's composition without the sulfur compounds that usually travel alongside it in natural bodies. To Loeb, that combination read less like raw asteroid material and more like a refined alloy, the kind of material you'd expect from something built rather than something formed by chance over billions of years. By December 2025, as 3I Atlas made its closest approach to Earth, passing at around 168 million miles away on the 19th of that month, moving at an estimated 153,000 miles per hour, Loeb had escalated his language even further. He told Sky News that encountering alien technology is like a blind date of interstellar proportions, warning that we'd have no way of knowing in advance whether we were meeting a friendly visitor or something closer to a threat. He developed his own risk scale from 0 to 10, where 0 represents an ordinary natural comet and 10 represents an active alien threat. As of late December 2025, he placed 3I Atlas at a 4. Inconsistent enough, in his view, that it couldn't be dismissed as a standard icy rock, but nowhere near confirmed as anything artificial. And here's the part of the story that a lot of the more sensational corners of the internet conveniently leave out. NASA's own scientists were watching the exact same data, and they weren't buying it. Tom Statler, NASA's lead scientist tracking the object, maintained consistently and publicly that all the evidence pointed to 3I Atlas being exactly what it looked like, a comet. A strange, ancient, chemically unusual comet, but a comet nonetheless. And in June 2026, the SETI Institute put the alien technology question to an actual instrument-based test. Using the Allen Telescope array at the Hat Creek Radio Observatory in Northern California, researchers scanned a wide range of radio frequencies, specifically looking for technosignatures, any sign of artificial signal or transmission coming from the object. They found nothing. 0. The team's conclusion, released publicly on June 3, 2026, was that this result was expected, because every other line of evidence, its composition, its outgassing behavior, its overall physical activity, pointed to a natural comet, not an engineered craft. So where does that leave the nickel, the missing tail, the improbable trajectory alignment? Mostly, it leaves them explained by conventional astrophysics, even if imperfectly, even if some questions linger. Later observations did, in fact, detect a tail, growing more prominent as 3I Atlas approached the sun and solar heating intensified, which is exactly what you'd expect from a normal icy body starting to outgas more violently the closer it gets to our star. The nickel without sulfur signature has precedent in certain rare comet compositions, even if this is an unusually strong example of it. And the ecliptic alignment odds, striking as they sound, are the kind of statistic that can look far more dramatic in isolation than it does once you account for how selection effects and survey biases shape which objects we're even capable of detecting in the first place. But here's why this argument never actually died down, even with NASA's rebuttals stacking up one after another. Loeb didn't go quiet. In January 2026, as 3I Atlas entered a rare alignment with the Earth and Sun that produced what he called a full moon phase, he reported a sudden brightness surge in what he described as a symmetrical three-pronged jet structure in the comet's activity. His now famous line to the Harvard Crimson, "Nature doesn't do perfect symmetry," He pushed further still, calling on NASA to release high-resolution images captured by the HiRISE camera aboard the Mars Reconnaissance Orbiter on October 2nd, 2025. Images he claimed had been taken but not yet made public, timed inconveniently around a federal government shutdown. He publicly stated, "The politics of the day should not sabotage science. They have the data. They should share it with scientists." He even proposed redirecting NASA's Juno spacecraft, already in orbit around Jupiter, to intercept 3I Atlas's path as it passed near Jupiter in mid-March 2026. An ambitious, some said unrealistic, real-time investigation of an object racing away from us at unimaginable speed. So, by the first half of 2026, you had two competing pictures of the same object, built from the same telescopes, argued by scientists who all had access to the same numbers. One side saw an ancient, chemically rare, but ultimately natural comet. The other saw a pattern of anomalies large enough and persistent enough that dismissing them outright felt premature, and sitting in the middle of that argument was 3I Atlas itself, utterly indifferent to the debate, still moving, still changing, and about to do something that would make both sides look at the data all over again. By March 2026, the argument over what 3I Atlas actually was had reached its final act, because the comet itself was running out of solar system to cross. Its next major waypoint was a close pass by Jupiter, scheduled for March 16, 2026, when it would come within roughly 53.6 million kilometers of the gas giant, a distance NASA's own tracking data confirmed with confidence well in advance. That number matters more than it sounds like it should. 53.6 million kilometers sits almost exactly at the edge of what's called Jupiter's Hill Radius, the theoretical boundary of Jupiter's gravitational dominance, measured at 53.5 million kilometers. In other words, 3I Atlas was going to thread the needle of Jupiter's gravity well about as tightly as an object could without being pulled into some kind of capture. NASA's assessment going into the encounter was calm and specific. Any perturbations detected in the comet's path so far were small and entirely consistent with normal outgassing physics, meaning the Jupiter flyby was expected to nudge its exit trajectory, not rewrite the story of what it was. Loeb, for his part, wasn't slowing down. As the comet approached Jupiter, he and colleagues at the Initiative for Interstellar Studies had already published a formal proposal, a real submitted scientific paper, calculating whether NASA's Juno spacecraft, still in orbit around Jupiter, could be redirected to intercept 3I Atlas during the flyby window. Their math showed it was technically possible. A precise thrust maneuver, executed as early as September 2025, followed by what's called a Jupiter-Oberth maneuver, could theoretically place Juno on a path to catch the comet on March 14, 2026, using its suite of onboard instruments, a near-infrared spectrometer, a magnetometer, an energetic particle detector, and a visible light camera. To study 3I Atlas from a distance, no Earth-based telescope could match. It's a genuinely bold idea. It's also, notably, not something NASA ultimately executed at that scale, and Loeb himself continued publishing his observations independently rather than through an intercepted spacecraft mission. Because here's the detail that should actually keep you up at night more than any single anomaly on Avi Loeb's list. 3I Atlas wasn't found by some enormous, purpose-built alien hunting observatory. It was found by a modest, automated planetary defense survey designed primarily to spot asteroids that might threaten Earth, almost as a side effect of its regular sky sweeps. And even Loeb himself, in the middle of his own case for the technological hypothesis, has said publicly that he expects new observatories to start finding objects like this every few months over the coming decade. Not every few years, every few months. That single sentence reframes everything you just heard. 3I Atlas isn't the ending of this story. Depending on who you ask, it might barely even be the beginning. The reason that prediction isn't just speculation is sitting in Chile right now in the form of the Vera C. Rubin Observatory, which only began its full science operations in 2025 and is expected to conduct the most comprehensive, continuous survey of the night sky ever attempted. Its entire purpose is to catch faint, fast-moving objects that older, narrower surveys would have simply missed, which is precisely the category 3I, our Atlas, Oumuamua, and Borisov all fall into. For nearly all of human history, interstellar objects have been passing silently through our solar system, unnoticed, because we simply didn't have the instruments to catch them. 3 confirmed. Detections in less than a decade, 2017, 2019, 2025, isn't evidence that visitors from other star systems are suddenly increasing in frequency. It's evidence that we only just built eyes good enough to finally start seeing what's always been there. That's not a comforting distinction if you're the kind of person who loses sleep over the unknown. It might be an even less comforting one if you're the kind of person who finds comfort in feeling like Earth is somehow isolated, sealed off, untouched by anything beyond our own solar neighborhood. The data increasingly says otherwise. So let's be precise about what has actually been established, because that's the part every viewer deserves before drawing their own conclusion. NASA, the SETI Institute, and the overwhelming majority of the professional astronomy community stand behind the assessment. The 3i Atlas is a comet, an extraordinary one, but a natural one. A comprehensive radio search using the Allen Telescope Array in June 2026 found 0 technosignatures. Every major deviation from normal comet behavior, the missing tail that later appeared, the unusual, nickel to sulfur ratio, the improbable trajectory alignment, has a plausible natural explanation grounded in known cometary physics, even if some of those explanations stretch the edges of what we've previously observed. That is the scientific consensus, and it deserves to be stated clearly and without hedging, because misrepresenting where the mainstream actually stands isn't skepticism, it's just misinformation with better lighting. At the same time, it is equally true and worth taking seriously rather than mocking that a tenured Harvard astrophysicist spent over a year building a documented, itemized case, 22 separate anomalies, published in the open, tied to specific dates, specific images, specific instruments, arguing that the technological hypothesis has not been definitively closed. Loeb has never claimed certainty. His own risk scale placed 3i Atlas at a 4 out of 10, explicitly short of confirmed alien technology, explicitly short of an active threat. What he has consistently argued for isn't belief, it's investigation. More telescope time, faster data releases, a framework for taking the possibilities seriously enough to check, rather than dismissing it by default because it sounds uncomfortable. Whether or not you agree with his interpretation of the anti-tail or the nickel ratio, that underlying argument, that we should actually look carefully every single time, rather than assume we already know the answer, is difficult to call unreasonable. And that's really the story this comet leaves behind, whether it turns out to be nothing more than a 10 billion-year-old snowball or something science hasn't fully accounted for yet. 3i Atlas forced 2 of the most credible institutions studying it, NASA's own scientific leadership and one of Harvard's most prominent astrophysicists, into open, public, sustained disagreement, using the exact same telescopes, the exact same published data, and reaching meaningfully different conclusions about how much uncertainty is acceptable before you rule something out. That disagreement is now baked permanently into the peer-reviewed scientific record in journals like Nature and Nature Astronomy, not on some anonymous forum. It's real, it's documented, and it's still unresolved by the time this comet slips beyond the reach of our telescopes sometime in 2027, carrying its answers back out into interstellar space with it, permanently out of reach. So where does that leave us, sitting here in July 2026, watching an object we can no longer even see clearly fade towards Saturn's orbit? And beyond? It leaves us with a genuinely rare kind of scientific moment, one where the uncertainty itself is the headline, not a placeholder for some more comfortable, more finished answer. 3i Atlas may never be visited, never be touched, never be definitively closed out one way or the other by the time it disappears for good. And the very next interstellar object the Rubin Observatory catches, quite possibly within months, not decades, according to the researchers who've spent the last year staring at this exact question, is going to walk right back into the same argument, with better instruments, sharper data, and a scientific community that has now, for the first time, publicly rehearsed exactly how this debate plays out. That's the real headline hiding underneath all the noise. Not 100 times bigger object appearing out of nowhere, but the honest, ongoing, unresolved argument over an object that's already here, already documented, and already forcing some of the smartest people on the planet to admit how much they still don't know. So here's the question worth sitting with as you close this video. If the next interstellar visitor arrives next year, next month, or next week, carrying its own set of anomalies, its own strange chemistry, its own uncomfortable statistics, will we actually be ready to look at it honestly? Or will we already have decided what we want it to be before the first photon even reaches our telescopes? Drop your answer in the comments, subscribe if you want to be there the moment the next one is found, and I'll see you in the next video.